thanks everyone for being here. I know you didn't really have a choice because this is the only talk going on, but appreciate that nonetheless. Yeah, so I'm going to talk about some work we've been doing with freshwater mussels and some analysis and interpretation I'm doing from metabarcoding data. So really quick, I want to introduce freshwater mussels if you're not familiar. Really cool group of organisms. I encourage go out and look into them if you've never heard of them. There's over 300 species in North America, and they've been hit hard over the last 200 years from all the activities humans have been doing. So in the U.S. alone, nearly a third of them are federally protected. So they're of great conservation concern, and they're just really cool. If you look here, we have images from a whole bunch of different species, lots of different sizes, colors, shapes, and I'm not even getting into their life history, which is a whole nother crazy thing that you should look into. But for this project that I'm going to talk about today, we were interested in doing an eDNA survey and compare that with some traditional surveying that was being done in Fish Creek, which is part of the St. Joseph River watershed, which is ultimately part of the Maumee River Basin, which flows into western Lake Erie. So the Fish Creek is in that blue region. It goes from Ohio into Indiana, and then ultimately back into Ohio. And we were interested in getting an updated inventory of what mussel species are present in this creek system, as a survey hasn't been done since the early 2000s. And it is the only known location of the white cat's paw, pictured there, which is presumed extinct, hasn't been found alive since, I think, like 1997. So we wanted to see if maybe we could get lucky and get an eDNA hit for that species. I'll answer that question right now and say we did not. So for this survey, we were sampling from 18 different sites, which spanned about 16 river miles, from starting down where the Fish Creek meets the St. Joe River and going up 16 river miles. And this was done in 2021 and 2022 in late summer, early fall, so about September. And there was 27 visual searches that were done, and these eDNA was collected at all 27 sites, but that eDNA was combined at some sites to be considered one eDNA site because those mussel beds were maybe 50 meters apart. So we didn't want to consider that two different eDNA sites. We lumped them together. So it's 18 total eDNA sites. And to just quickly go through the methods, we were collecting triplicate water samples per site on glass microfiber 1.2 micron filters, 1 liter water samples per filter. DNA was extracted with a QIAGEN DNeasy kit, and then for PCR amplification we're using a 16S assay that's specific to unionid mussels, and PCR was done in 8 replicate PCRs per sample that were then pooled together for sequencing. Sequencing was on a MySeq, and then for data processing it was done quality filtering was done in data 2, and then sequences were clustered using vSearch at 97.5% similarity, which then was assigned to taxonomy with a custom database based on the species that we knew were present in the system. But I want to get into this sort of data analysis interpretation a little bit here with this talk. So here's a result of the entire data set, a list of all the species found visually and with eDNA. I've listed them from most abundant mussel to least abundant mussel. Everything that is green is a species that was detected with both methods. So what we can see is there's a lot of green. The one yellow species is a species that was missed with eDNA. It was only found as a single individual in the entirety of Fish Creek, so very rare. And then eDNA did detect 4 species that were not visually observed during our surveys. But what I want to really focus on is sort of site level detections. And so this is showing all 18 sites and all species that were detected throughout Fish Creek, and then whether we visually observe them. If we visually observe them, there's a number there, and that's how many individuals of that species we observed. And then a green box means we detected that species at that site with eDNA. A red box means we did not detect that species. And so if we look at the Venn diagram, the first takeaway here is that there was 162 visual observations in this data set, and 152 of those 162 we confirmed with eDNA. So really high overlap there. But what was striking to me is there's 157 times we're detecting a species, but we're not visually observing that species. There's a lot of green empty boxes here. There's a lot of times where we're saying there's eDNA, but we're just not visually seeing that species. And that got me thinking, how can I make this sort of a more representative of the visual survey? Because eDNA, we're detecting things that are farther from our mussel bed that we're directly on. So how can I maybe look into this data a little bit more to have a more comparable interpretation? And what I looked at is 2 parameters to set what I'm calling a detection confidence level. The first one is on the bottom here, the number of replicate samples that a species is detected in. Because we're taking multiple samples per site, that was my first parameter. So I just said if it's only detected in one of our samples, that's a rare detection, and I'm going to have low confidence in that detection. If it's in more than one, it could be a medium or a high confidence. And then I had another criteria there, which is based on the reed abundance, the relative reed abundance that species was within the mussel community at that site. Now I used 0.5, and I'm biased there because of the way the data worked out. I'd love to talk to people about what makes sense here, because I don't know the answer to that. But 0.5, I really liked it here. Majority of the times the species showed up in only one sample, it was less than 0.5% of the reeds. So these are very rare detections, so they're falling out into this low confidence, and that made me feel fairly comfortable in the data set here. And now, so here's showing that site level detections again with our confidence level colors. And we can start to see there's more colors than just green, right? And when there's a complete green for a species, typically that species is found nearly at every site with the visual survey as well. So that was good to see. And if we look at our 162 detections with visual surveys, we can see that 75% of the time we visually observe a species, it falls into the high confidence detection criteria. So that, I like that too. I think that's good. 75% of the time we know a species is there. We're very confident in it in the eDNA as well. And then only 2% of the time that we visually observe a species, it's in that low confidence. So majority of the time we have these low confidence hits, we're not actually seeing that species at that site. I also looked at this based on abundance and how that's playing out in these different confidence levels, and not surprisingly, as the confidence goes down, the mussel abundance that we're visually observing goes down. So if you're getting these low confident detections and the species is truly there, it's going to be very rare within the system. All right, and I wanted to make some comparisons or look at some trends across the river for this data set, comparing the visual survey to these different eDNA data sets. So this here is showing the trend in species richness from the visual survey across the river. And then that's a box plot in the corner showing the average or the mean species richness per site. And we can plot in our data sets here to see how they compare to our visual results. This is with all of our data, including the low confidence data. We can see our mean species richness per site is way higher than our visual results. If we put in the medium confidence data, so we've thrown out all the orange hits, we're only looking at mean, or the medium confidence, comes down a little bit, still above our visual expectation. And then our high confidence has pretty much overlaps completely with the visual data. Another way I wanted to look at these comparisons is a plot here that's showing the mussel abundance for a species at a site compared to the proportions of sites that are occupied by that species within Fish Creek. So this is the visual data, and you can see, this is an expected curve that as a species becomes more abundant in the creek or river, it occupies more sites. And so we can see how eDNA data compares to a curve like this. And here's the whole data set. We are likely overestimating occupancy here, perhaps, well above our visual expectation. Of course, it comes down a little bit with the medium confidence data only, and then we have complete overlap of those confidence intervals with our high confidence data. Now, I want to make a point here that I'm forcing eDNA data to an imperfect survey. We know that that dashed line is not right. Our visual surveys are not great. We know that that data is not perfect. So I don't think the green line is reality either. So it's a question, what is reality? Is the yellow line maybe better? I don't necessarily know the answer to that, but I think putting these confidence on different detections maybe allows for better interpretation of hits instead of just saying any detection counts as a species being there. At least now we can say, okay, maybe it's in low abundance or maybe it's upstream. It allows for different interpretation of the data. And the last point I want to make before wrapping up here is that the low confidence detections are still important and shouldn't be discarded. This species, the salamander mussel, is a really unique species. It uses the mud puppy as part of its life history, where it's parasitic as a as larvae on a mud puppy. And so what that means is it lives in the habitat of mud puppies. It lives underneath rocks, really hard to survey locations. We didn't visually observe it, but we detected its eDNA throughout Fish Creek, which is important because we can say, okay, this species is still extant within Fish Creek, but I don't think we can put any confidence that we know exactly if it's at any of these places we're detecting it necessarily. We know it's somewhere around there, but I can't say, oh, it's for sure at river mile 2.7 and 2.8, right? So that's where I'm kind of going with this confidence level here is, okay, this is useful data, but we can't hone in on exactly where this species is. All right, with that,